Hi, this presentation continues the series on multiple regression and focuses on different methods we use to build regression models. Multiple regression introduces us to another issue in statistics, which is how to build or construct a model. Many statistics offer multiple methods by which a model can be developed. We will discuss three methods in this presentation. The method of building the model will be responsive to our research hypothesis and will alter how we interpret the overall model and the individual predictors. In the first type of model building method will be called the standard or forced model. In this model, all predictors are entered into the equation at the same time or on a single step. The example we cited in slides earlier, in earlier presentations, used a standard method of entering predictors into a model. This method considers the influence of all variables, but is not necessarily designed to test research hypotheses about individual predictors. Rather, our focus is on the relative importance of individual predictors. In hierarchical regression, predictors are added in steps. Variables can be entered singly or in blocks with other variables. For example, researchers commonly add a set or block of demographic or control variables in one step, and they might add a block of personality traits in a second step, and so on. Hierarchical methods are considered driven by the researcher's theory. In other words, the researcher chooses the order of variable entry consistent with the theory used to define the model. For example, some predictors may be added prior to others because the researchers hypothesize that the influence of some predictors occur before others in time. In another example, researchers may wish to enter broader social variables first, such as demographic and community factors, before entering individual level predictors. Researchers will also use hierarchical regression to test for hypothesized mediating or moderating effects. In psychology, a common use of the hierarchical model would be to enter control variables in the early steps and then enter a key test predictor on the last step. In this way, researchers are attempting to test the primary test predictor's ability to predict variance in the criterion after considering the effect of the other predictors first. You will hear researchers refer to the effect of the primary independent variable as being above and beyond the effect of the other predictors. This process of testing the key variable using hierarchical methods is considered a conservative test of the key variable's impact on the dependent variable and is in wide use. Let's look at an example. In 2011, Baharasa and colleagues studied the effects of family conflict, psychological distress, and life satisfaction on academic performance in Asian American college students. In the first of their studies, they hypothesized that family conflict would predict lower first semester GPA above and beyond control variables. They used a hierarchical multiple regression to analyze this hypothesis. They entered a series of control variables on the first step, and then they entered the key research predictor, family conflict, on the last step. The control variables were a combination of demographic and family variables and an academic aptitude measure represented by the acronym AAR. The table presents the findings from the study. Note that in the first step, the model consisting of only the control variables accounted for 10% of the variance in GPA, grade point average. The researchers also found that generation status and socioeconomic status made significant unique contributions to the prediction of the variance in the criterion. On the second and final step, the researchers entered the key research variable, family conflict. To interpret this finding using our template, we would say that the null hypothesis that the predictor failed to make a unique contribution to the prediction of the variance in the criterion in the population was rejected because the probability associated with the test statistic was less than alpha. We found that increases in family conflict predicted decreases in GPA, and that 4% of the total variance in the criterion was uniquely predicted by family conflict after the other predictors were partial or semi-partial. The researchers reported R-squared change equals 0.04 when family conflict was added to the equation, and because R-squared change equals SR squared, we would say that 4% of the total variance in GPA is uniquely predicted by family conflict. On the last row of the table, the researchers reported that the coefficient of multiple determination for the entire model was significant and accounted for 14% of the variance in the criterion. Although the researchers didn't report PR and SR for the individual variables, we can consider the size of the beta as an indication of the relative importance of the individual predictors in the model. Family conflict, generation, and SES are crucial predictors of GPA. A final method of building a regression model is called statistical regression. In this method, predictors are added to the equation in steps, one predictor at a time, using a variety of statistical algorithms. In forward selection, the equation starts with no predictors in the model, and then predictors are added one at a time, and at each step, the predictor that's added that has the largest remaining semi-partial correlation squared. The procedure continues until adding new predictors does not make a significant contribution to big R squared, or does not significantly improve the ability of the model to predict the criterion. Thus, it is common for fewer than the entire number of predictors to actually be selected into the final model. In backward elimination, the equation starts with all predictors in the model and proceeds to remove predictors on each step with the smallest SR squared. This procedure continues until removing a predictor results in a significant decrement in big R squared. Finally, stepwise method combines both forward and backward selection. Statistical methods to build models are not widely used because they're generally considered to be searching for a model rather than the theory-driven test of a model in hierarchical regression. In general, there are few examples of statistical regression currently being used in clinical research.